Yes. The other half of the class is gone for the college fair. We're going to go on and do the notes for it today. Because the way that this works out with this chapter and next chapter as it sits with doing the lesson today, because we'll cover the lesson today. Tomorrow will be the makeup day. Friday will be the review. We'll go over the review Monday, and then the test, I believe, is 2 parts. Then we'll start chapter 4 out of the green books and pretty much go each day. We won't have time for a makeup day to be able to do the review, go over the review test before Thanksgiving break.
And is the chapter 4 test, is that the semester content?
That would be, it wouldn't be, because that would lead us up to Thanksgiving break.
Oh.
And then the test after Thanksgiving break would be, the chapter we cover after Thanksgiving break will be our midterms test. It's just going to be over that chapter. So there's just enough time to hit each one. The additional makeup day would throw a wrench into everything, unfortunately. Now, what we're doing today isn't too complicated in what we're covering. Now, the first thing we're getting at in the last way to solve quadratic functions is the quadratic formula. Now, what I'm going to do here first, I'm not going to have you write down because it's going to take more space than what you have, and I did that on purpose. Now, we said the general form of any quadratic equation comes in the form of ax squared plus bx plus c is equal to 0. This is any quadratic equation. Yes, for any values of a, b, and c as long as a is not 0. And we said that the completing the square method will solve any quadratic equation, no matter what it is, yes? I'm going to apply completing the square to the general formula. So our first step was to say that a cannot be anything other than 1. A has to be 1. Well, here we actually do have an a value. It could be 1, it could be something else. So we're going to divide, I'm going to divide each term by a. And if I do that, we would get x squared plus b divided by ax plus c divided by a is equal to 0. Might as well give a whole lot of extra room. Now our next step was to get the variables on one side and the constant terms on the other. It's c divided by a. C and a are just 2 real numbers, so it's just a constant term. So what that leaves us with is x squared plus b divided by ax plus blank is equal to negative c over a plus blank. Well, different c, but we're finding the c term to make our perfect square trinomial, which would be our b value over 2 squared. Well, the b value is b over a. Now, b over a divided by 2 actually works out to be b over 2a. Well, b squared is, well, just b. 2a squared, 2 squared is, so we have 4a squared. So here is going to be b squared over 4a squared. B squared over 4a squared. Well, this polynomial will factor down into x plus b over 2a, because that's the term inside the parentheses before we squared it, yes? Now, over here, to be able to add these two together, we need the denominators to be the exact same. So to do that, I need to multiply numerator and denominator by 4a. which the denominator would be 4a squared. Now on top we do have b squared minus 4a times c is, well, 4ac. We can't really combine any of these farther than this here because a, b, and c, they could be the same value, but there's more likely chance, there's more possibilities of them being different values than them being the same. Well, what did we do next in the process? We would square root both sides because the square root and square would cancel, leaving us x plus b over 2a is equal to, well, plus or minus. I'm going to put it plus or minus b squared minus 4ac. Because we can't take the square root of b squared minus 4ac. It's not something that we can rewrite as a set of parentheses squared or simplify in any way like that. But the denominator, what's the square root of 4? Square root of a squared, which is a. So the square root of 4a squared is 2a. And last but not least, to get x by itself, we would subtract b over 2a from both sides. X is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Well, the denominators are both the same, aren't they?
Yes.
We can put them together. X is equal to negative b plus or minus the square root of b squared minus 4ac all over. This should look familiar, because I believe it, I don't know if it's still hung up now after the floods last year that shut down Miss Kendall's room and that whole wing from the sprinklers busting. But yeah, but before that, the poster that was above Miss Kendall's door when you leave was this right here. This is the quadratic formula. Now, the reason I went through that is not because you have to actually see that, because you're never going to actually have to work with that ever again, any of what we just did. But what this does show us is two things, or what it shows y'all is two things. One, it shows us how we get this formula. And two, well, the completing the square method, as we've seen, works with any polynomial function, or any quadratic function. It will give us the answers to the quadratic function, yes? Well, if that's true, and we applied it to the general form, this equation should also give us all the solutions, or both solutions, for any quadratic equation. And that is true. So if we let a, b, and c be real numbers such that a is not equal to 0, then the equation ax squared plus bx plus c equals 0 are, the solutions for it are x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And that is the quadratic formula for any quadratic equation. We can use this here to find the solutions. We're ready to look at the first example. So we have the quadratic equation, x squared plus 3x plus 5. X squared plus 3x equals 5. If we're solving this using the quadratic equation, we need this thing equal to what? Okay, what do I need to do to get it equal to 0? Subtract 5 from both sides. Because those would cancel, telling me that x squared plus 3x minus 5 is equal to 0. What is the value of A? B? C? A is 1, B is 3, and C is -5. Now the quadratic equation was x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Plug it in. So negative, what's the value of b? Plus or minus square root. Well, we need to simplify, but that will give us the answer. So once we get the values or get the equation for get the quadratic equation equal to 0, we take the quadratic formula and plug in the values of a, b, and c. Now, when we look at this here, x equals, we have -3. So that would be -3. Plus or minus square root. I'm going to get a highlighter. At this point here, I would type everything that's inside the parentheses into a calculator. Because we could do it by hand. Because I could do 3 squared, which would be 9. I could do -4 times 1 times -5, which would give me 20. Oh. There we go. And it would tell me that it's 29. Over, because 2 times 1 is 2. Now, is there a chance that the number where the 3x or 3 squared minus 4 times 1 times -5 could be negative? Yeah. Because when we had our imaginary solutions, or our complex solutions, we got it because there was a negative inside of a radical, yes? Because the square root of -1 is I. So there is a chance that the number inside this radical could be negative. And there's also a chance, because if we take the square root of 29 in the graphing calculator, it will give us a decimal, because there is no square root of 29 as a whole number. So plugging it as the square root of 3 squared minus 4 times 1 times -5 into the graphing calculator would give us an answer, but it would give us a decimal answer. Because if we're not looking for approximations, we want the exact answer, we want to leave it in radical form. So, well, what calculator will leave it in radical form? Yellow. The yellow. But if what's inside the radical is negative, will the yellow calculator simplify it? Well, no. So it's good to simplify what's inside the radical first to see, is it going to be a positive or negative number? If it's negative, like we've been dealing with before, we take out I and then let the yellow calculator simplify it down. Well, as we said, there's no way to simplify the square root of 29, correct? That's as simplified as it gets. That's it. The only way that we would simplify down is if there is a greatest common factor with both of the numerators and the denominator. So if there's a greatest common factor of 2 between the numerators, both of them, and the denominator, then we could have simplified it. Otherwise, we're done. Because we cannot add or subtract -3 in the square root of 29 without turning it into a decimal. So that's the answer. Questions on this here? We're ready to look at another one. Solve 3x squared plus 4x equals 10. What do we need this equal to? Yeah, we need it equal to 0, so how can we get it equal to 0? Subtract 10 from both sides. So negative b, what's the value of b? We have a, b, and c. Plus or minus the square root of 4 squared minus 4 times a is, and c is all over 2 times 3. So the first real step for solving these with the quadratic equation is, one, making sure the quadratic equation is equal to 0. Then we take the quadratic formula and plug in the values of a, b, and c. And for here we get negative 4 plus or minus the square root of 4 squared minus 4 times 3 times negative 10 all over 2 times 3. All right. Well, at this point we just need to simplify down. Really, I could have written parentheses around the 4, but it'll just tell us that it's negative 4 plus or minus. And again, 136. 2 times 3 is 6. Now we do need to check to see if 136 will reduce at all, and it should, because I would check it with the TI-30XS to see if it does reduce in simplest radical form. And what the square root of 136 will reduce to is to do the 2 square root of 34. Now we're not completely finished here, because there's 4 and 2 and 6. Do all three have a greatest common factor? 2, yes? Now, what we can do is we can think of it as this way. I can factor the 2 out, which would leave us with negative 2 plus or minus the square root of 34 on top. On bottom, we still have 6. What is 2/6 reduced to? So we say the denominator is 3, and on top we have negative 2 plus or minus the square root of. And that's it. So that is our final answer there. Any questions on any of this here? Let's look at least one more, because I think y'all are getting the handle on this. Yes? We feel good with these? Let's do this one here, because I do know that this will give us imaginary solutions. Now this one here, is the equation equal to 0? Well, yes, it's already equal to 0. So we can see values of a, b, and x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, when I plug these in, there are a few things I will do automatically. One of them is negative b. That's our first one, is plugging b in for negative b, yes? So what are we going to have? Negative b is negative 6, yes? So we're saying that we have what? Negative 6, which would just be what? Really, negative b is just saying that we're changing the sign of whatever b is. Since b was negative 6, it's now positive 6. Since I noticed that, I will go on and just plug it in as 6. That's one of the two things I will do as I'm plugging them in. Is flipping a sign, that's fine. That's not overly involved. Plus or minus square root, I will still leave it as negative 6 squared minus 4. Well, the value of a is 1, and the value of c is, yeah, so we could say 4 times 4. That would be perfectly fine too. Now the denominator is 2a. What is a? 2 times 1 is? Those are the main two things I will do when I plug it in. I'll change the sign of b, because we flip it. Negative b is just changing the sign from positive to negative or negative to positive. And even if a has a value, we're just multiplying it by what? I will simplify those two things on the first step when we plug it in. The next thing I would do is find out what goes inside the radical. So 20. So this one does not have imaginary terms, but the square root of 20 would reduce, because 4 times 5 is 20. Square root of 4 is 2. When we have the square root of 5. Is there a greatest common factor between the top two and the denominator? Yeah. Well, yes. They all have a greatest common factor of? And we're really just dividing that out, yes? What is 6 divided by 2? 2 square root of 5 divided by 2 is? We could have done a similar thing on the last one and saw, okay, the first one was 4/6. Well, that reduced to 2/3. The other one had a 2 and a 6. It would reduce to 1/3, so we're just left with the radical. We have that there. Now, if not all three will reduce, then we won't really reduce it, because the only way to do that is to split the two apart. But if it can reduce and stay as a whole term, either as a fraction like we saw in the last one, or all the way down to where we just have two terms, we need to do that. Now, if we can actually add or subtract these, we need to go on and do that. Because if it had just left us with 5 instead of the square root of 5, we had 6 plus or minus, well, it'd be 10. Divided by 2, we need to actually find out what the value is. Here, because of the square root, we can't simplify it any further. We are done. Questions on this here? Do we need to see another example using the quadratic formula? Let's look at, because I did provide a few. Oh yeah, let's look at this one and the next one real solution, one imaginary solution. So this one here, 25x squared, I think is at the top of the second page, or first page, back of the first page. With this here, we need this equation equal to 0. what we can from both sides, which will tell us 25x squared minus 20x is equal to and then we can add 4 to both sides, telling us that 25x squared minus 20x plus 4 is equal to we want to get everything on the same side. So let's start plugging in. So our first thing is negative b. Well, what's the value of b? Negative 20, so negative b would be positive 20. Because negative 20, negative and negative make a positive. So we just have 20. Inside the radical, we would have negative 20 squared minus 4. Well, a is 25 and c is 4 all over 2a. Well, what is a? 25, and 2 times 25 is 50. Now our next step was to find out the value of everything inside the square root. So parentheses negative 20 squared minus 4 times 25 times 4. And if we plug that in, we get negative 420.
No.
Did you put the parentheses around the negative 20? We got, and we got 0, yes? Because 20 squared is positive 400. 4 times 25 is, times 4 is, so 400 minus 400 is 0. Well, this whole thing is just 0, yes? What's 20 plus 0? 20. 20 minus 0 is? So really we're just left with 20 over, which means x is equal to? So here we do have technically 2 solutions. They're not unique solutions. The solutions are both x equals 2/5 and x is equal to 2/5. Any questions on this here? Let's definitely do this one. For 2 reasons. 1, we're going to have imaginary solutions, and 2, the value of a is negative. I want to show you an example of this here. Now the first thing we can do is we need to get this thing equal to 0. So we can subtract 13, which gives us negative x squared plus 4x minus 13 is equal to 0. Because we need to get all the variables, everything on the same side and equal to 0. So x is equal to negative b, bless you, plus or minus the square root of b squared minus 4ac all over 2a. So what is the value of b? 4. So negative b would be negative 4. Because if b is 4, negative b would be negative 4. Inside the radical would be negative 4, or just 4 squared. Eraser, erase. I'm going to try that again. Because it's just going to be 4 squared minus 4. Well, a is negative 1, and c is negative 13. And this is all over 2 times. 2 times negative 1 is negative 2. So now we need to find out what 4 squared minus 4 times negative 1 times negative 13 is. And this is all divided by negative 2. We need to simplify the square root of negative 36. Because the negative inside the square root of negative 36 would come out as I. The square root of 36 is 6. All over negative 2. Now, before we go dividing or doing any simplifications like that, if there is a negative in the denominator, we can move it up to the numerator, because we don't like having negatives in the bottom of the fraction. So it's perfectly fine to move it up and say negative 4 plus or minus 6i all over 2. Because we're essentially factoring out the negative 1 from the denominator and multiplying it through the numerator. Let's see what happens. Well, negative 4 times negative 1 would be 4. We still have 2 on bottom. Well, the negative times our plus, positive. Negative times a positive is a. The negative times the negative is a. So it still gives us plus or minus. So I show you that because we could have just simplified it with the 2 all in one step. But if we have a problem where it won't simplify down, because if we had 3 and the square root of 7 over negative 2, well, the 2 won't simplify with either, but we can still do this step with negative. Now, will both 4 and 6 divide by 2? So we can pull that out. 2 divided by 4 is plus or minus 3. Questions on this here? Now, the last thing we have is the discriminant. The discriminant is the part contained inside the square root of the quadratic formula. Now, there's 2 things that we could have, or really 3. B squared minus 4AC can be greater than 0. B squared minus 4AC can equal 0, or B squared minus 4AC is less than 0. Now, if B squared minus 4AC is greater than 0, we have 2 real solutions. Bless you. If it is equal to 0, we have 1 real solution, and if it's less than 0, we have 2 complex solutions. But if it's greater than 0, we'll have 2 real solutions. They might be whole numbers, they might be irrational numbers, contains a radical. If it's equal to 0, well, we saw that one today, because if it's equal to 0, that entire plus or minus is gone. We're just left with negative b over 2a. In imaginary, or our complex solutions, if what's inside the radical is less than 0, well, we're going to get a term with I, because it's negative, and it'll give us 2 imaginary or 2 complex solutions. questions on this here? Find the discriminant of the quadratic equation. Describe the number and type of solutions of the equation. So they're wanting three things. So find the discriminant of each one. So our b squared minus 4ac. So what is the value of b? So we have negative 6 squared minus 4 times at this point here, we just need to type it in to get the answer. Now, negative 6 squared would be 4 times 1 is 4, times 10 is 36 minus 40 is. So the discriminant is negative 4, which is less than 0, so we will have solutions. Any questions on this here so far? Now we need to find out what they are. Describe the number and type of solutions. So if I remember correctly, and I will look back at the assignment just to make sure, they want us to actually find it with our x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we said b was negative 6, yes? Well, negative b would be positive 6 plus or minus the square root. What is b squared minus 4ac for this here?
Negative 4.
And a is 1, so it's over 2. Well, we already found b squared minus 4ac. We found the discriminant already. Now we just need to solve. 6 plus or minus. Because the square root of negative 4, well, the negative would be I. Square root of 4 is 2. And if we divide both of these by 2, we get x is equal to 3 plus or minus I. Any questions on this here? Let's just look at, for the next two, we'll look at what the discriminant is and the types of solutions. So here, our discriminant is still b squared minus 4ac. Well, b is negative 6 squared minus 4 times 1 times 9. Well, this would be 36 exactly minus 36, which is 0, which means we have one real solution. And really that solution would be 6 over 2, so x is equal to 3 if we worked it out. Now the last one, b squared minus 4ac. Apparently they don't like changing the value of b for any of these. So b is still negative 6 squared minus 4 times 1 times 8. Well, 6 squared, negative 6 squared is still positive 36. 4 times 1 is 4 times 8 is 36 minus 32 is, so we have what? 2 real solutions. And we could plug it back into the quadratic equation to find out what those solutions are. Any questions on any of this here? We good with this here? And these here would be the same type of thing that we just did. I'm not worried about the real world problem. But that's it. That is all we are doing for today. And that wraps up chapter 3. We're officially done with chapter 3. Let me look at 21 through 24 real quick. Because I do want you to do those with the discriminant. Okay. So for the homework assignment for 21 through 24, you're going to be finding 3 things. Like we did with the first one, you're going to be finding the value of the discriminant. What is the value of b squared minus 4ac? What does it tell us? Does it tell us it is 2 real solutions, 1 real solution, or 2 complex? The book will call it imaginary if you look in the back to check. And you need to find the solutions, like we did with the first one. You need to see what is the actual values to solve it. So you're solving it, finding the value of the discriminant, and essentially telling us what the discriminant tells us. Is it 2 real, 1 real, or 2 complex? And it's only for 21 through 24, the last 4. The rest of them is just using the quadratic formula to solve the quadratic equation.